Alright guys, I think we are live. This is my dog. Her name is Angel, so this is just so you guys can know her. Yeah. Okay, the idea today is to go through some text mining concepts. We're gonna touch a little bit about machine learning also. So I will be using the scikit-learn as the main library for that. Let me share my screen. All right, you should be able to see my screen now. All right, so the tutorial that I'm gonna be basing on today will be a tutorial from Kaggle competition. For those of you who never heard of Kaggle, Kaggle is like a machine learning community. So there's a lot of really interesting stuff going on here, and they promote these competitions. So there are actually competitions that you can even gain prizes, actual prizes. So companies publish their data. So there's all kinds of competitions, and one of these competitions that happened a couple of years ago was about trying to predict the sentiment of a reveal for a movie. So the data that we are touching is a small subset of the data from IMDb. I believe everybody heard about IMDb. If you didn't, just type imdb.com and check out what that is. So before we actually start coding, let me just spend a couple of minutes try to cover the concept of the bag of words representation and what a vectorized representation of text data can be. So bag of words is a really common name when we are dealing with text mining and text processing and machine learning dealing with text. So sometimes you also hear that the instead of text you hear like unstructured data, because text is pretty much most of the time text is not really in any kind of pattern, predefined pattern. So it's just like a reveal that somebody posted on a site, or is some kind of post. Like imagine the content from a website like Stack Overflow. So anybody can go there and post some question, and something else goes there and post an answer, a possible answer, and then it goes. So text is usually dealt as unstructured data, because there's no really pattern, predefined pattern for how you're gonna actually store things. So you don't know a lot. That's in opposition to like the more traditional structured data, like a database, like a DBM. When you have a DBMS, you are storing your data in a very specific kind of way. So you like on a field, you can only store like a number of a specific kind, or a string with a certain length. So there's a lot of rules that apply. So this is in opposition to the structured data. That's what we are going to touch today. So then it comes this definition of bag of words. What would bag of words actually be? Bag of words is a really common term in text processing, and it pretty much is the idea that a document is just a set of words. So there's no it doesn't imply any kind of relationship between the words, or even like if you have a composite word, it doesn't really take that into account. So or the position that the word is in the document. So like if you have imagine the word natural language. So if you have instead language natural in a different order, that'll be just the same for the representation that we are going to do, which is the bag of words representation. It will just be the same. So and this term bag of words is exactly that idea. I mean, you're just getting words and throwing into a bag, and you'll kind of lose the information, the original information about the order or the context that word was in. It's also important to say this is not like the only possible representation for a text, for a word in a text, but this is really used, and because of its simplicity, and also because of the results that we are able to get with this kind of representation, we end up, I would say most of the time we are actually using bag of words representation to deal with text. Okay, let me also show the link for this tutorial actually. This is kind of a big one. I'll just paste that in the group so you guys can check there. If you prefer to search, you can just use the name of the competition. So if you come here, let's go to the home of the competition. It's called Bag of Words meets Bags of Popcorn. So this is the name of the competition. At least I believe it is. Yeah, I think so. You can use that to search inside Kaggle or Google, whatever. Okay, so let's and now to actually start our coding. There's one more thing that I have to talk about, which is the way that we use to represent the text. Actually, the bag of words concept actually is it doesn't really tell us how you're gonna organize the words into a data structure. So there's a very popular kind of construct called inverted index. So the idea of the inverted index is basically build a data structure that can be searched or queried by a word term. So to build that, we just go through the whole corpus that we have. Like, let's say we have like 5,000 documents. You go through every single document, scan it, and extract the words. So you keep like getting this information from these words, and you can use one of the ways that we can store this information is just to count the number of occurrences of a specific word. So if you have a word that happened like 2 times in the document and 4 times in another document, so you have a overall term frequency of 6, which is 4 plus 2. So this kind of idea. It's also a really simple idea, but it allows us to use the word as the query to consult this data structure. So it's very different from the original storage of the text, because it's a lot more efficient actually. So imagine having to search a like for you have a big data set with a couple of millions of documents, and each of these documents has a lot of text in it. So imagine having to search for a specific, or for a document that has a specific word or a word inside a document. So that would be a really consuming kind of job for a computer. Even like it will actually grow pretty much linearly with the size of the data that you have. So if you build this inverted index, you actually are able to search based on words, query based on words a lot more efficiently. And the complexity actually would be, if I'm not mistaken, log of n in this case. So it really is a very efficient way of representing what you have. Okay, so I believe now we can actually start coding. So if you are going to do what I'm about to do, I would actually I would suggest that you read more carefully this tutorial, or even consult other sources. We're gonna just go quickly through the code, so we don't like spend a lot of time in this. So the first thing that we are about to do is read the data that we have from a file. So if you scroll up all the way in this page, you will see that there's a link here called data. So here you can go, click, and actually download the data for this competition. The data that we're gonna use is, at least for this example today, is only this last one. So this will be called labeled train data.tsv. So I had already downloaded it in my computer. Let me locate it. Yeah, that's the one, labeled train data.tsv. And we can take a look at the contents of this file. If you check the file after it is unzipped, it's a 30-something megabytes. And let me open a terminal here. Let me clear this. So where are we? TSV. Oh, here you can see the same file, but in a terminal. And we can print the first line of this file to have an idea of this. So most of the file that we use most of the file will be CSV files, but TSV is pretty much the same as a CSV file, but just instead of a comma, you have tab to separate the fields. So here, the first line is a header, and most of the time you will have a header as the first line. So it just brings like the labels for each of the columns. This is a really simple data set. So I have 3 fields, which is ID, sentiment, and review. ID would be just a number to uniquely identify the role that you have. The sentiment is it'll be either 0, 1, and 0 would be a bad sentiment, and 1 a good sentiment. You can read a little bit more about how the sentiment was calculated on the Kaggle page. But this is actually the thing that we will try to predict. So the goal of this competition is actually try to predict if a review is a positive review or a negative review. So it can be modeled as a binary classification test. So binary because you only have 2 possible labels, being positive and negative, and classification because you are about to predict which of these labels, which of these classes should my data be in. So let me also show not only the first line but the first 2 lines, so you can also get a feeling of how the data actually is stored in this file. So here we have now the ID. This whole thing is the first row. Okay, this whole thing is only 1 row. So here I have the ID, here I have the sentiment. So 1 is for positive, and here I have the whole text of the review. So here is what we call a unstructured kind of data, because here I don't have like I could have like a metric of some kind. I could have tags. I could have all kinds of different things, but I'm not really using anything other than the target that I'm going to try to predict, and the whole corpus, which is the whole text content of the data set. One thing that we could also use on the terminal to determine like the size of this specific data set is the word count command. So I can just, if I do WC minus L, I could check the number of rows that I have in my file. So here we see that we have 25,000 in one lines in this file. The first one being the header, of course. All right, so I think we can move to the actual coding now. Make sure you have this file downloaded. Okay, let's go back to the tutorial page. And I'm gonna use, as I most often use, I'm gonna use a Jupyter notebook to do our experimentation. Also has to do a disclaimer. I only started trying out pandas now, so I'm still kind of learning how to use Panda. There's all kinds of pandas is a package to, among other things, it can be used to read data and represent the data in a more easy easy to process kind of format. So, but it's not the only possible way that we have. We actually have in Python, we have a lot of different possible ways of doing that, of reading data from a file and storing data structure. All right, so there's also an interesting link here right after the code header. There's a link that you can open, and this link will take you to this GitHub page. So you can either download this one or copy paste the information from here, however you prefer. In this case, this script is ready to be run as a command line script for Python. That's not how we're gonna do today, but that, just so you know, you can also do that. All right, so the first task that we have to accomplish is read the data, collect the data from this file. So here I'm gonna do a pretty much the same way that this tutorial is showing. So we're gonna use pandas package to read this file. The function that we're gonna use is called read CSV, and even though it is called read CSV, you can still specify that the limiter is not really a comma. So in our case, we are specifying that the separator is a tab. So a tab character is the actual separator in our case. So make sure you import Panda. Most of the time you will use this alias PD. So that's really common for pandas. You can just stick to it. And then here I'm creating a variable which will store the contents of this file. In my case, I just took the whole path and put here plus the file name, and I specified the header to be the first line being the header, and the delimiter as a tab. I don't know specifically what quoting equals 3 does, but I'm just copying how the tutorial has done it. So let's run this one. Well, after I run it, now I have the data, and the data into the data variable. So I can just check here, like the type of variable that data is, and you will get pandas core frame data frame. So data frame is how pandas call the way to store the data. Let me actually clear all these. I'll put clear, yeah. All right, better now. So what if I want to know, like, how many rows does data has? I can use the length, which is a short for length. And you see there's 25,000 rows. Not every data structure will actually be compatible with length, but most of the data structure are compatible with length. So length is like a built-in function available for Python. So most of the time you can use length, But if it doesn't, the only actual case that len could not be used that I went through so far is when you are using NumPy arrays. So I think that's the only actual example that I can remember. All right, so data has a lot of possible variables. We can actually check that. If you put in Jupyter Notebook, if you put a variable dot or object dot something and use the tab, it'll offer to autocomplete, so you can live just check everything that you have, both variables and methods that you can run. So in my case, I just want to check the column names. And here we see that we have these possible columns. If you observe, this is exactly the header values. So this just matches the labels for the header, which is the first line of our file. So now you can actually go and select one of these columns. Let's say I want to check out the ID of my first, let me don't delete this, of my first row. So here I'm selecting the column using a string to do that. So this is pretty much how a dictionary works. And then after that, I am selecting the row that I want. So it's like imagine this as a two-dimensional array or a matrix, and then you're pretty much first selecting the column and then selecting the row. This is specific to this order is specific to pandas data frame. So not every kind of data that you're going to use in Python that will actually make this kind of selection available. So you have to, this is very specific to what the data kind you are dealing with. All right, so let's run that and see. So here I see the value for the ID, first line. I could also not do this selection, and let's see what happens. In this case, it will print the first ones and just use these 3 dots and then print the last ones. So you don't have a really huge output. In our case, let's leave like we left before. And let's say I want to know the sentiment of this first row. So let's just change it here and observe. Okay, so sentiment is 1, which means positive. And let's say I want to see the review or the raw text for this review. So here I have it. When you have a really huge string like that, you can also use the slicing to limit your output. So I can just, let's say I want the first 100 letters only. So that makes it more reasonable as an output, especially for notebooks. All right, so now we have a pretty good understanding of how to consult, how to use the data that we have loaded already. Now we're gonna move to the next step, which would be use scikit-learn to build our inverted index. So in order to do that, I will need the count vectorizer function. And this function is this is actually a class, the count vectorizer class. And this class is available on scikit-learn.featureextraction.text. So you can use this kind of syntax, so you don't have to use the whole path as when you call it, when you call count vectorizer. That makes it easier for you to code. All right, let's run this, and after I run it, I pretty much have it loaded. So the next step would be to use the vectorizer. The vectorizer is like a structure that would just basically allow Python to go through a bag of words representation and actually build the bag of words representation based on a raw text. And you will probably want to have the data stored in rows. So if you have like reviews, in our case, these are reviews. So for each review, the best way to represent would have each review being in one line. So that will make the things really easy. That's kind of implicit on most of the machine learning tests that we do actually. All right, so here we actually don't even need this first one here. I'll just specify that the maximum number of features that I want is 5,000. Even these I don't really need, because if you check the documentation for a count vectorizer, which I'll search right now, scikit-learn documentation, count vectorizer. So if you check the signature for this class, there's most if not all parameters that you can use are actually they come with defaults, so you don't have to actually worry about it. If you don't specify, it will just default to what's determined here. So in our case, I'll just leave us with this parameter here, just to limit the number of features to 5,000. And this will run pretty fast because right now, until now, I didn't do pretty much anything. The next step can be a little bit slow depending on the size of the data that you have. So this data is not really big, so it will not take long, but still can take a couple of seconds depending on the machine that you are on. So I'll call the resulting data that will be generated, I'll call it data underscore v, just to make sure this vector representation and differentiate between the data, the raw data, and the vectorized version of the data. So also, this method here, fit transform, it actually does two things. The first thing that it does is it takes the corpus that you have, which is the whole set that you have, and it scans it so it can build a dictionary, because the vectorizer will need a dictionary, which pretty much is just a list of possible words that you're gonna use. So it builds the dictionary in this first step, in the fitting step, and in the second step, it will get for each document, it will actually scan which words are present. So it will transform that specific document into a vector representation, which is, in this case, just the number of times a word happens in that document. So you will have, in a moment, we can consult how the data will actually be, but this would just turn a document into a list of indexes for every possible word that you have on your dictionary. So this is what we call a vector space representation, because the document is transformed into a list of indexes. So that's it. So let's run it. If you take a look here in the top right hand side, right after the Python 3 name, there's a dot that blinks when something like the kernel is running. So you can check when it is running. If this is filled, that's because it is running. When you have steps that takes more time, see here, it'll turn white in a moment. When you have more computing intensive tasks, it will stay on for a while. In our case, again, just as a reminder, this is a really simple, a really small data set. So this will run pretty fast because of that. All right, so data v, let's try to determine what kind of variable that is for data v. So here you see that the kind of variable for data v is a CSR matrix. This is a SciPy or NumPy kind of data structure, which pretty much is a sparse representation of a matrix. So it's a more efficient way of storing a matrix, especially when we are dealing with sparse data, which really is the case when you are dealing with text. So you will really want to use this kind of representation as much as possible for dealing with text. And in the next step, let's see the size or the length of the data V. So I could try the length here, but as I told before, a NumPy array will not actually give me the length in this case. So if I do that, I will get an error because the sparse matrix length is not really something available right away. So I can use instead the shape to check the dimensions of my matrix. So here I have a matrix which is 25,000 rows wide by 5,000 columns wide. These 5,000 columns is related to the features that we had specified. So if I didn't specify that I wanted only 5,000, these would probably be a bigger number. You can also use, like, let's say you want just the first information, you can, in this case, do like 0, and then it would just return the first, which is the number of rows that you have, or the number of features as 1, and it will return for you. And my vectorizer, after you fit it, you have a vocabulary available. So this vocabulary will store all the terms that you have and also the frequency for each term. So let's see the length of this vocabulary. All right, here I have, as expected, I have 5,000 words or features. That's because I have specified here that my count vectorizer would have to be limited to that amount. And I can also consult which type of data vocabulary is. So we see that this is actually a dictionary. So a dictionary is a very common kind of data in Python. And as a dictionary, you can just see the contents just by calling it. And here you see that we have keys as the word and a number as the count for this word in the whole corpus. So this is the number of times this word appeared on every document that you have on your data. If you scroll, you see that there's a lot of values because these are the number of features most of the time will be in tens of thousands of features. If you don't limit it, it will pretty easily go beyond 10,000. So let's just clean this cell to make it easier. And as a dictionary, I can use the index to consult the value for a specific word that I want. So in this case, the word arrived stores the value 309, which is the number of times that the word appeared, as we talked before. Now let's see how the data, the vectorized version of data, is actually stored in our data. Here, I am selecting the second occurrence of my data. I could use any index here. Actually, this starts at 0, so 0 is the first one, and I'm using, as this is a NumPy array, so I can use this function to turn into a non-sparse representation. So this allows me to do things like slicing and other operations. If I leave it as a sparse representation, so I will not be able to do the slicing that I want. So if I do that, I also has to, since the way that the NumPy stores these vectors, we will see that these will return to us a vector. So is actually array of an array. So there's 2 dimensions involved. So because of that, I always has to use the 0 after that. And then here I'm just saying that I want the first 300 occurrences of, I mean, the first 300 terms or words. So let's run that. So here you see, since this is a sparse matrix, we will have a lot of zeros, and a couple of words will not have zeros, which means like for this word, I have 1 occurrence. For this word, I have 2 occurrences. For this word, I have 4 occurrences. So this is pretty much how it is expected to be. If you don't slice it, you will just have a pretty big representation. Actually, it's so big that you can't even, like, NumPy does that trick to not mess with your output. So we'll just leave like I did before. And also a very useful function that we can use is this get feature names available for the vectorizer. So here you will see that it will return the words which actually match the keys for the vocabulary that we have, which is a dictionary. All right, so let me clear this cell, and let's get back here to the tutorial. So you see there's a lot of things here that you should take a look into. We don't have the time to go through everything now, but I only want to show one more thing, which is the classification using a random forest classifier. Where is that? All right, it's here. Yeah, so the tutorial uses the random forest is a kind of a tree-based classifier. I'll just skip the explanation for what random forest actually is. For now, just take that's a kind of a classifying algorithm based on trees, and it just allows us to make a classifier to try to predict the class or the sentiment that we want to for each of these reviews. So I will need to import the random forest classifier. Good. And then I will need to instantiate it. You will need to specify the estimator for the tree. So these, depending on the size of the data set, we will need you will pretty much tune this value, because random forest is a very CPU intensive kind of classification model. So you might need to actually go down depending on your on the size of your data. All right, so we instantiate it and we fit it. So when we instantiate, we only, like when we did with the vectorizer, we only specified parameters for the model. So the next step would actually be to fit the model with the training data. In our case, these actually are not the same name that we are using. So instead of train, we will call it data, as we did before. And what is that train data feature? Let's see what that is. Train data features. Okay, it's the vectorized version of the reveals. Okay. So here's just data v. So just to be clear, here I am trying to predict the sentiment, and in order to do that, I am using the vectorized version of my data. So that's pretty much the input for this fitting process. As you see, this might take a while. Let's wait a little bit for that. And while we wait for that, the next step would be to do the actual prediction. So there's usually, for scikit-learns, there's usually a method called predict. Let's check. Where is it? Here. So here, it's pretty much predicting. We'll have to wait a little bit for it. So as I said, the random forest is not really a quick one. If it takes too much, I'll just reduce the number of trees. While it is doing it, I will start setting up the next cell. See, while this is filled, the kernel is still running. So I'm editing here, but the kernel is actually doing the processing for the previous cell, as these asterisks here can actually tell you also. So in the case of in this data, in order to actually evaluate, I will, let's see, let me check the documentation. I will try to use a how's it called? Score accuracy, some accuracy score. That's the name of it. Yeah, accuracy score. So so far I'm not concerned about actually splitting the right way training versus testing set. So I'll just postpone that for the next times that we do some classification tests. I'll just calculate the accuracy for the whole training set that we did. So we would expect to get a good result, but be clear that this actually would be a metric for the training, and that really doesn't tell us a lot for a real world classification test. So we will have to import this one here. This is called the data view. Okay, it finished. So let me run the next one, which would be the prediction. And let's import the accuracy metric. Let's see what we need. Okay, here I need Y for the true, Y for the prediction. Okay. So here will just pretty much be the prediction results here and the target values here. So let's say DSC score. Data sentiment. And prediction will be the results. Okay, so here we go. Amazingly good accuracy, 100%. As I told you, this is a training accuracy. So you would actually expect a really good result here. Not always you will get 100%. These accuracy scores varies from 0 to 1. So a 1 score would pretty much means 100% classification accuracy. Okay, I think we can stop for now. I hope you guys had a feeling of dealing with some data. There's a lot of things that we can cover. I was expecting to actually cover the TF-IDF factorizer also today, but I'll leave that for a next opportunity. But I hope you guys had a good taste of how to do this kind of tasks on a Python environment. And let me actually, I'll paste this URL on the text pad so you guys can more easily consult it. Leave it here for a couple of seconds, so it makes it easier to just pause the video while you type it. As I said, I'm also gonna paste this link in the group, the Google groups of our club. All right, guys. I hope you guys have enjoyed this one, and we see each other in the next one. You guys have a nice time. Take care.